Afternoon, everybody. Thanks for sticking it out to the late afternoon sessions today. My name is Jamie Gray. I'm with Stewart Engineering in Raleigh, North Carolina, and my co-presenter is Mark Packelhofer. Get that right? Yeah. He's with the City of Durham, and we're going to be talking to you about a project that's currently underway to take a second look at an existing sewer inventory that the City of Durham put together several years back, bring some consistency to the data, bring much higher quality XYZ surveyed locations to the features, and this is all to support a very large water model that they're doing in South Durham currently. And so this is the way this is going to work. Mark's going to kind of take over and set the stage, kind of tell a story a little bit about the background of the project, some of the things that were necessary to do this, and I'll come back in and talk about the logistics about collecting the data and bringing everything together. And then Mark will come back up here and just kind of wrap up with some pretty good summaries, some good benefits that the city is expecting to get out of the data set and the model. So I'll hand it over to Mark.
Okay, to get started, so we're going to cover a little bit about the project, why we are using a mobile GIS, the data collection, which Jamie's going to cover as he said, and status reporting. Then I'll go over some future benefits that we expect to get from the study. So the study covers approximately 131,000 linear feet of sewer main and 1,600 manholes. And this is just for the southern portion of Durham. We also are doing the same thing in the northern portion when they're finished. We expect all this to be done, or the contract has it set to be done within a 4 to 5 month time frame, and it started in December of 2018 and is going to April of 2019, hopefully. That's assuming everything goes according to plan and there are no flash floods and hurricanes or anything like that coming our way. Some of the key goals that we are looking to get out of this are to have confidence in the survey data from the manholes, and that will hopefully help us make a more robust GIS system, which in turn will help us create a more robust sewer model. I don't know if any of you guys are familiar with sewer modeling. I used to work in the field, but elevation data can be one of the limiting factors in sewer models if you don't have everything set up correctly. And if the inverts of the manholes are slightly above where they should be. So why did we choose a mobile GIS? A mobile GIS will help provide situational awareness. So not only will it help the managers, the project managers, it's also going to help the field workers or the people collecting the data out there. And And that's going to allow people, that will allow the project managers to know where the field workers are. And in certain cases where residents call in and they have complaints, or a resident calls in and says, there's some city guy in my yard, why is he here? Is he supposed to be here? Somebody can respond appropriately. So another reason that we're using the mobile GIS is to help keep track of our inventory. We want to be able to keep track of completed versus incompleted data. And it will also help provide confidence that the manholes being surveyed are in the correct location and the correct manholes are being looked at. So we envision that the field workers are out there with their mobile GIS unit, ArcGIS collector is, I believe, what we're using. And they're out there, they can see the background, and they're kind of lining up what they should be looking at with what they have on their map there and plotting the point down. So all in all, what we're really trying to do is reduce the human error as much as possible. And the mobile GIS units also help with the fact that the app is easily deployable. You can provide it to anyone and anybody very, very quickly on any type of device. The apps will also help improve consistency from the use of subtypes for certain fields, such as pipe material, diameter, status, whether it was completed or not completed, and who took the data or who edited the data. It's also a lot easier to go back that way if there are inconsistencies somewhere that we're finding, and be able to maybe pinpoint what may have happened or who may have done it, and maybe a device malfunctioned or there was something else going on. So this is sort of what I was talking about with data inconsistency, and this is what we're trying to prevent. This was taken, or this is from a data model, sewer data model that was currently being worked on in Sewer Gems. And as you can see, there's this inconsistency here with the invert data for the manhole. And that can cause all sorts of problems. And usually it's pretty easy to troubleshoot by just looking at a profile. But in some cases, with people less familiar with the program, it's harder to find. But very easily fixable. There are tools internally to be able to interpolate between one point and the other point for that to be fixed. But ideally, you would rather have the manhole survey data. Jamie, take over. Thanks.
All right. So I'm going to talk about the data collection in a little bit more detail about what we're doing out there in the field with the collector app and some traditional survey and how we're bringing all that together into a final deliverable. Like we mentioned before, there's approximately 1,600 manholes out there in this particular sewer shed. You know, some of the pain points with some older, more traditional ways of going about doing a project like this is particularly with multiple touches on the data. We're typically, and I'll show you an example in the next slide of a field book with a hand sketch that somebody's got to take that and put it into AutoCAD or GIS or whatever. So all of a sudden you've got all these touches on the data, and every single time you put it through that process, you're kind of increasing the chances of something getting mixed up or whatever. I like this method too on this large scale project because it gives us a big picture perspective on where the project is, where people are working, particularly if you have multiple crews out there. It's important to avoid people stepping on each other's toes, doing work that's already been done. So we're handling some of that with the GIS method on this. And then kind of on the back end, to prevent some of those inconsistencies in the data, keeping it all into a GIS allows me to do a lot of automated QC checks here and there without that are quick to do, very effective. Most of the time, we've got thousands of manholes out here, and 95% of them are good. But how do you know what 5% might be bad or needed to take a look at. And automating that QC in GIS is the best way to do that for sure. So this is kind of a typical field sketch of what surveyors have done for decades and decades when it comes to particularly stormwater and sewer inventory type work. You know, I kind of look at a sketch like this as kind of like my nightmare. I don't really want to deal with any of that. It's small, you know, you would have hundreds of pages of these, you know, real small scale. It's hard to read people's handwriting sometimes. Sketches aren't really to scale, so it can get kind of confusing about, you know, if you connect it up to scale, it doesn't look like the sketch. All sorts of problems with that. So, but this is kind of what it looks like now. Instead of the field sketch we look at before, we have a lot of base map data in there. Everything is to scale. They have, fortunately on this project, the city of Durham's sewer inventory was pretty robust. So I just took their inventory and we're basically editing it where we need to out there in the field. It's good for the situational awareness, like you mentioned. You know, we can see where we are on our phone or iPad relative to everything else around, so we know we're, you know, surveying manhole ABC instead of XYZ. And we can give them all sorts of data on, you know, facility IDs. They don't really worry about that kind of stuff, but it's in there. So this is kind of what, you know, our new, you know, collective version of doing this kind of work looks like. And then it doesn't all get done within Collector app. Definitely the attribution, the invert measurements, all that gets done in the field in Collector. But since we're using our survey equipment, our, you know, survey grade GPS receivers, we have to use total stations quite a bit, you know, going through the woods where we can't use GPS. That becomes kind of a back-end issue on how do you associate those XYZ coordinates from our data collectors to these particular facility IDs in the GIS, because that's how everything is related, is based on the facility IDs. So that's kind of a you know, an ARC desktop exercise. I'll typically use a spatial join command to get the facility IDs onto the points, because I don't really want anybody manually entering in a 12-digit facility ID that's supposed to be on a certain point. Things can kind of go sideways real quick if you've got, you know, manually entering that stuff. Mention again the automated QC checks. It gives me, you know, a very high degree of confidence in the data before we turn it in. You know, the modeling software has a lot of real quirky rules about how different elevations relate to each other, and if something breaks the rule, it kind of like blows them all up. So so we can go ahead and take that pass on the data, make those adjustments, and hopefully, you know, the goal is to provide our client a data set that they can just ingest in their model and start using immediately. Another big part of this for us and for the city of Durham and our stewards actually working for Friesen Nichols is our client who has a prime contract with the city of Durham. This is a dashboard that I put together for using Web App Builder for everybody to kind of see what's going on with the project in real time. You can see we've got, you know, different colors on the nodes up there. You know, the green ones, they've been surveyed, no problem. The red ones, we've had a problem, whether it's behind a locked fence or it's bolted shut and we can't get into it. Too high above the ground that we can't get it to it without a ladder. All those kind of issues that are going to come up on a project like this. We flag them with a comment, and the city of Durham and their inspection folks and everybody have access to this to where they can go to one of those flags and say, okay, they're locked out of the fence here. Let's send one of our techs out there to let them in or arrange for a way to work around that kind of stuff. One of the cool parts of this, depending on how you look at it, I've got a widget in here that kind of keeping everything. It's all about trust. We're keeping ourselves accountable to the schedule, how we're doing in relationship to that. It works awesome as long as you're at or ahead of schedule. The bad side of that is if you start slipping behind a little bit, I might get a phone call from Freese and Nichols saying, hey, you should be 5%, because I've got a little baseline schedule up here so they can look to kind of see where we are. And, so it's one of those things that can be a blessing or a curse. Fortunately, it's worked pretty well. It's kept us on top of it. I stalk this thing on a daily basis, typically just to make sure we're not getting too far behind. But that's an important part that, really gives a level of service on transparency to a stakeholder or a client to feel like they're a little bit more part of the project. They can, go into one of these flag things on the web app and read the comments, share those internally. So it works really good, and it's got a really positive response for them for kind of being engaged in the project on that level. So with that, I'm going to turn it back over to Mark to kind of summarize things from here.
Yes. Okay. So some of the future benefits that we're hoping to get from this study are a more consistent and robust data set, which is going to help with better sewer remodel results and long-term helping locate areas in need of work. Currently, there's not a real schedule or anything put forward to do some of the sewer work. We just are kind of pinpointing things that we think at this point need to be updated. So this is a very big thing for us. And in the end, will hopefully save us a lot of money and a lot of time. We're also looking with the sewer model to mitigate problems before they actually occur in the field. And with the Sewer Gem software, there are many modules and many functions that will help with that. And finally, we're trying to look to develop a process to incorporate the data that we have into the GIS. So previously, my understanding is that the data that has been collected from a few other surveys that we have done has gone directly into the sewer model and did not make it into our GIS system for one reason or another. So we're hoping to do this last time here and get everything incorporated correctly. Those are some of the major benefits. I'm sure there will be other ones that are currently unforeseen, but that's what we have for you today. Are there any questions? Yes. It's the Sewer Gem software. Bentley Sewer Gems, if you're not familiar. Yes. Yes.
The short answer to that is no, but the longer answer to that is that now that there's more, for a while there were some receivers coming out, survey grade receivers, and they had to play, at least the one that I've looked at a year or two ago, had to play a little bit of catch up before it was going to be able to get integrated into Collector. But yeah, Stuart's actually on another team, and we get to keep the band together with Durham. We're going to be doing the North Durham Basin as well, which is right about the same size. So just knowing that, that's something I'm interested in looking at for sure.
Anybody else? Yes.
So your teams, when they're out there, you talk about, are they kind of devices doing GPS work.
That's right.
And they're also doing collector work, but those two things are talking to each other, so you have to kind of merge them together.
That's right. That's right.
In the office.
Yep. Yep. And then what he mentioned too about some of these, asset type GNSS receivers that can, that you don't have, they can talk to each other between the receiver and collector. So that's definitely something that would save that step for sure. But as of right now, collectors basically just replacing their field book and pencil essentially. Yeah. So it's going to be two different processes no matter what, but I definitely prefer this process over the field book for sure. Anybody else? Okay. Well, thank you very much.
Thank you.